This talk is about building an operator for a machine learning example. Actually, I had never been before in a project where machine learning was involved, but I was with that curiosity and started learning for my own and digging and doing my own research. Where here, I'm going to share you one of the experiments that I've been doing. Well, just a little commercial. I am part of the Go community in Guadalajara, Mexico. Here are our social media. On the team also are Rodo, Gustavo, and Luis Esteban. So you can reach us if you have any question, and you can check our YouTube channel. We have some talks. Most of them are in Spanish, but there are a few in English. Okay, well, about the problem and demo to show in this talk. This is about a system that is able to do canary tests with different service deployed. In this case are models, that services. The idea behind a canary deployment is to introduce a new version of the model by first testing it using a small percentage of user traffic. And then if the new model meets the set requirements, then we increment the traffic from the old model to the new one. So, well, basically, we will have a system where we are going to do that canary release. For that, we are going to use Kubernetes. Also, we are going to make use of a technology called Istio for the networking. And also, we are going to have Go code, of course, for our operator. So, let's dig in. Okay, for this demo, we are going to be focused on the process of taking a trained machine learning model and making its prediction available to users or the system. What I mean for that, as you can see on the slide, there are like two different processes. The first one on the left is related to building a machine learning model, and on the right side is where we are going to focus. That is where we are going to serve that model, and we are going to do that canary release. All right, just to warm up a little, I'm going to show you a little example where we are going to deploy a Tensorflow model. And for that, we are going to also make use of a service. We are going to deploy a load balancer in order to test it out. And also, as you can see, we are going to make use of cloud storage in order to have our models already there. So we are not going to be worried about training and doing the model. So we are going to take a model that is already trained and there. We are going to use also the Kubernetes engine for our cluster. So I'm going to change to the code that I have here. Here we go. Can you see my screen with Visual Code, I think? Yeah, right.
Yes, we can see it, Guillermo.
Okay, just testing out if it's available. So I will continue. For the deployment of a model with TensorFlow, we are going to use a technology called TensorFlow serving. So for that, it's very easy on the deployment spec. The only thing that we need to do is just to set the name of the model, in this case, as an argument, and where the model is stored. Once we have set that, and also to expose the related ports. In this case, with TensorFlow serving, it is also support to have gRPC on the 8500 port. And if we are going to use HTTP, is in this port. So this is pretty easy. We just set the path of the model, the name of the model. And then as I mentioned on the diagram, we are going to set a load balancer as a service. So let's see how it works. Let's deploy this. Here we go. Okay, it's already created. So right now the service and the deployment is deploying on the cluster. So let me see if I have the endpoint for the load balancer for that. I just missed a W here. Okay, it's still building the endpoint for that, but while it's building the endpoint, I am going to show you how to do that call. For doing that call, we are specifying that we are making use of the HTTP port that we define. The path is models. This is the name of the model that we define. And in this part, we are going to say that is a prediction. This model is what is going to do is going to give us a prediction of an image. It's going to tell you what is inside of an image. For this example, I'm going to use the image of Grace Hooper. So we are going to make a call with this image, and we are going to see how the model performs with that. So as you can see, now we have our endpoint, and we are going to test it out. We're going to be careful here, paste it here, and cross fingers that this will work. So it's sending all right, we got the response, okay. As you can see, we saw that the model find out that there is a unique military uniform, and is 45% secure that it is that. And he find another things, and it gives another probabilities. So this is like how to deploy a model with TensorFlow. So let's use, this is like the first part. The second part is about Istio. Istio is a service mesh that provides us a way to secure, connect, and monitor service. For this demo, we are going to use all related with the traffic management, but Istio has other features, for example, for flexibility and also for security that you can take a look. It works. All right then. So we saw a little introduction about Istio, but before going through the code to the Go code, I'm going to give you some theory about the Kubernetes API. Okay, every resource type in Kubernetes, like pods, deployment, services, and so on, is a member of an API group. For example, in this case, we have the jobs resource that belongs to the group batch. In the case of pods, it belongs to the core group and also has a version. Well, and then we have groups and we have resources, and then we have versions. With that versions, that allows developers to introduce breaking chains to the APIs and manage them as they do. So it's kind of the theory of how the API in Kubernetes is done. So now we're going to start working on the Kubernetes programming interface for Go. The Kubernetes project provides a number of third-party libraries under the Kubernetes organization on GitHub that help us to program for Kubernetes applications. So the Kubernetes project mainly has these three packages for doing our Go code. The first one is a client Go. That is a web service client library that supports all API types that are officially part of the Kubernetes. It also has something called the client set that we are going to see later. The API machinery, it has where all the generic building blocks to implement the Kubernetes-like API. And finally, we have the Kubernetes API that it contains the Go types for objects like pods or namespace and service and so on. We are going to see this in an example in order to see how this library fits. There is another one that is for controllers that is called the runtime controller it is also important. Let's see now, we already deployed with a jump file TensorFlow model. Now we are going to modify that model in order to serve it to the same to a same endpoint from another deployment. And we are also going to deploy the key components from Istio in order to do the shifting traffic and do the canary. For that, I'm not going to do this in YAML files. We are going to go directly to the Go code. In that way, I'm going to show you how to use that package. Sorry. So let's go through the code here. I'm going to show you that. All right, then. So this is the first example we code. As you in this example, what we are going to do is to do a simple deployment of the other model. Let me see what other, and also update the other model with the new values. So for starting this, as you can see, here we have the package that I mentioned before. The Kubernetes API is where we have about the types of the deployments, and here where we have the types of a pod. In this case, as you can remember, inside of deployment, we have in the template also an object of a pod. That's why we have this here from the API core. These three packages are more related to building the client set that will do the calls and will build the path in order to do the calls. So this first part, we are only defining our client set. It is called client set because it gives access to clients for multiple API groups and resources. What is that? As I mentioned before, deployment, services, and so on, they are like in different groups. So once we have the client set, we create a new object for our deployment. Is kind of, as you can see, this first part is where we define the metadata, is related to the API machinery package. Here we define the spec, where it's a deployment spec that is inside of the Kubernetes API apps. Here we are like building our objects, and this is the part where we actually do the call in order to create our deployment. First, we define our client set, and we say, okay, it's from the group's apps version 1. Is a deployment resource in the next specified, and then we create that deployment. So it's kind of similar of the build pattern where you are building the URL and then you make the call. So for updating the previous model that we already deployed, we just get the model that we already called, and we do the change on the name of the model, and then we update it. So very straightforward, I think. So for that, I'm going to run this script. It's in the plan. Well, I run it here above. And as you can see, if we saw all the deployment, you can see our previous model and the new one that we create from the code. So let's continue. As you can see, we have libraries for the Kubernetes native objects like pods, services, and so on. But what about custom resource definition? How we can actually interact with them? How can I, for example, in the previous diagram, we saw 3 components from Istio that are CRD from Istio. So I'm going to show you how to do that. The first one is using something called the dynamic client set that is from also from the Go client. The dynamic client set has no knowledge about the resource you want to consume. It does not provide a helper methods as we saw like core v1, .pod, apps v1, .deployment, and so on. Instead, you will need to provide something called schema group version resource, which is a Golang type that provides the necessary information to construct the HTTP request to the cluster API server. So here, the first steps, you create the REST config, then that is passed to the dynamic client. That is the one that creates that client to connect to the CR resource. And this is the part where you create actually that part of the where is going to be making the call. As you can see, well, I'm going to create a gateway that is part of a system to make it work or shifting traffic. I already know that is part of the group and version. For exploring the group version control, there is a command here in kubectl in order to see that. So if we run kubectl, the command is API resource. So kubectl API resource resources is like that. Sorry. So here we go. Here we have our resources. Also, we have the part where we have the in which group belongs, and also the version. We can find here gateways. That is part of the beta 1 of the network Istio group, beta 1, B1, beta 1 version, and gateway. So, okay, so let's deploy this gateway. Istio dynamic. All right, then the gateway is running. Next option, as you can see, for doing that, you need to specify this, and also for doing the call, as you have to do like make use of a map string interface, which is like, well, not messy, but there are better ways to communicate with the custom resource definitions. So you have another option that is writing your own Go code in order to build the objects like we have for deployments for pod for your own custom resource definition. It takes a lot of boilerplate. It's a not long process, but it is a process, you know. So, but fortunately for us, we have from Istio, we have a library also for communicate for the objects, and that library is called the Istio Go client. So let me show you an example. For the Istio Go client, as you can see, Istio already has their own objects defined for that. So for example, we are going to create a destination rule. Okay, it's already here, the object, and you just put the information that you will need, and that's it. For building the client, it's not the same client set as you get from the Go client. You will need to have, you will need to set the client from Istio, that is here. So as you can see, it's a client set from the client Go, but from Istio. So now that we have our objects from Istio and their own client set, this is the call for creating the destination route. Let's test it out just to create it. So the version. Okay, we have now the destination rules. Now, as you can see, it's another client. So if we are going to build a controller, we are going to have like two clients different, one for Kubernetes and another for Istio? Now, it actually is not like that. We can rely of the package that I mentioned before that is called the controller runtime, which allows you to have just an interface for having the both client set. I'm going to show you that in this another example. In this another example, we are going to make use of the runtime controller from Kubernetes in order to build controllers. So here, what we do in order to have like the two client sets is you need their schemes. And that's it. You create a scheme for that. You add that scheme to the scheme from the Istio and also from Kubernetes. You will be able to run commands. You will be able to use Istio objects like in this way. And also we're going to be able to get Kubernetes objects. In this example, what I'm showing you is just a single command where I get the previous service that I deployed on the first sample. I update it because I'm going to remove the load balancer and just change it to cluster IP in order to have both deployments on that service. And here I'm going to create the virtual service that is the one that allows me to do the canary test. Here is where we define the percentage of traffic. So let's run that. So cross fingers, seems to be working. I don't know. We are going to test this. So with that, we deploy the components from Istio, the deployments from the Kubernetes native objects. So we are going to be able to test out this diagram that I showed you before. So let's see. For that, I have already here the endpoint. I changed for both deployments the name of the model in order to have the same path here. So let's test it out. This IP is from the gateway from Istio. I already know it. I put it there. So let's test it. Cross fingers, please work. Don't die. Okay. So as you can see, now it's taking the new model, and as you can see, it is like it has more probabilities that says that there are a military uniform from the same image that I test from Grace Cooper. So if I run again this, it should, okay, as you can see, we shift traffic 50-50. So in that way, we are going to see, okay, this model performs better than this one. So we are going to change to that other model. So this is part of the code. I'm just going to remove what we already have just to give some space for the operator that we are going to deploy. I'm just removing, cleaning up. That's it. Okay, let's continue. Go controllers. Well, in a few words, a controller is an entity that is continue measuring events from the outside, and then it's trying to get a desired state. What I mean for that, for example, a thermostat, where you said like, okay, I want to stay I want to set this temperature, so the thermostat will be continue looking for, okay, this is my temperature, I will need to change to that. In that part where it's like measuring and comparing, is called the reconciliation step. There is some theory for the controllers. There's more terms like the watch, listen, and that. But I will just go to the practical side and try to skip that part. So just for letting you know about what is a controller and why it's needed. Okay, for this example, we're going to be an operator that will be in charge of doing that canary test. We can do all the whole process deploying component by component from Istio and then from Kubernetes and so on. But we can have it in a single place. We can create a custom resource definition where we can set that specifications, and then we are going to deploy some Go code in order to watch that specification and say, okay, here we are setting traffic, each percentage of traffic. We are saying here that we need that model. So this is what we are going to do. Operators are like software extensions to Kubernetes that make use of custom resource definitions to make application and their components. We are going to make use of the operator SDK because it's designing for providing the all necessary tools to build, test, and package operators. And also it's kind of easy because I'm going to show you an example where you are just going to focus on the logic and on the permission that will need the controller. So let's see. This is what we are going to do. We are going to create a custom resource definition where we are going to set all the information needed. In this case, we are going to create one that is called TF Canary. And the thing that we are going to set is the name of the model, the location, and the weight. So this custom resource is not existing. It's something that I invented. Maybe there are another one that, but this is the one that I am going to show you on the demo. So, well, this is our like steps just to let you know that how easy it is. You just create the project, create the API and the controller. Here you define your group. It can be like your core ML group or whatever. No? You define the version, very important, and the name of the kind. In this case, the kind was TF Canary. Once you have that on the code, you go through the code and you have to manually set the, we are going to see in the later how to do that. You change the types. You say, okay, I will need an array of models, and the model is an struct that will have a path, weight, and a name. So you define that. And then some commands to generate that the Kubernetes manifest needed for deploy your operator. In this case, we are going to be implementing also Istio. So you are going to need to also add a third-party resource, which is very easy. We already saw on the example that I give you where we only add the scheme. And well, this is like the steps for creating a controller for focus on the logic. The code on the controller, the only thing that we'll do is just we'll be looking in each reconciliation cycle. If there is no resource for that, it will create it. If it is already created, so and there is a chance, it will update the resource. As you can see, we need to create a deployment service and all the Istio custom resource definition. And well, this is for specifying the permissions. In order to, you can run locally your operator with this command. As you can see, operator SDK gives you the commands quick make. You can build it, and then once you have all that steps, then you are ready to ship it with that command. So let's see the code now. The code for the operator is this one. Here is the structure on the left. We have the API where we have our schema defined. Then we have the types. As you can see, I create use a struct of model and an array of models where we have our models running, and also it will have this parameter that is weight that we will set the percentage of traffic. The logic of the controller is here in controllers, where you can also make tests. And here is part of the logic. Here we specify the permissions for the Istio, the core group, apps. Here is where the logic goes. That is inside of the reconcile method. You write all the code necessary for creating the deployment, updating the deployment. Well, it's kind of large. But yeah, you make use of the objects of Istio, and then you make use of the objects from Kubernetes. Finally, the main file. Here is where I specify the schema from Istio, and then you have all running. All right, so let's run this. here in config, we have all the YAML files necessary for running your project. Right here, we have our definition for the new custom resource. So let's first deploy this operator. For that, I'm going to use deploy for an image that I already built and test. I'm sure that it will not break, or I think so. So let's see. We are now deploying our operator. Let's pray, cross fingers, whatever. Okay, here we go. Now that we have our operator there, let's apply this change. We are going to apply a configuration for this definition where we are going to say, okay, I want 100% of my traffic of this model. That is the one that was performing bad. So if we do that, it will deploy everything. So let's test it out. I said that the name of the resource will be the endpoint. So that will be here. So let's test it, or maybe wait a little until it's deployed. Let's do it. Okay, 404, let's see. Let me see why. Maybe. I'm going to let's see. Dun, dun, dun. Demo is not working. Should I? Actually, it doesn't create anything. That's weird. Well, I don't know. Just to to not wasting time. It's something happened, but eventually, what I was about to show is that if we do the same process of making the URL specifically, we will saw that changes. So something happened later. I will see that. This was about the demo. About testing, I haven't tested, as you can see. Maybe for that it was breaking, but well, it is use something called Ginkgo. With that framework, you can test it out and make it work. Another options for ML application are Kubeflow. It is already designed for this. They have also custom resource definition for distributed training, something like that. So it works to take a look. Finally, well, this is some of the, some links that I've been studying in order to build this. In the first part is where I have the code from the talk. And this another, if you want to learn more, good practices that I think I was not following, but you will see. And thank you. That's it for me. Yeah, thank you.